physicist Stephen Hawking on the future of space exploration. From George Washington University, this event is part of a series marking NASA's 50th anniversary. It's about 45 minutes.
Not much needs to be said about Professor Stephen Hawking, who is one of the world's foremost cosmologists and astrophysicists. Since 1979, he has been the Lucian Professor of Mathematics at Cambridge University, a seat once held by Sir Isaac Newton. And with that, I would like to introduce and welcome Professor Hawking and Lucy. Thank you all so much.
Can you hear me?
Yes.
Why should we go into space? What is the justification for spending all that effort and money on getting a few lumps of moon rock? Aren't there better causes here on Earth? In a way, the situation is like that in Europe before 1492. People might well have argued that it was a waste of money to send Columbus on a wild goose chase. Yet the discovery of the New World made a profound difference to the old. Just think, we wouldn't have had a Big Mac or KFC. Spreading out into space will have an even greater effect. It will completely change the future of the human race and maybe determine whether we have any future at all. It won't solve any of our immediate problems on planet Earth, but it will give us a new perspective on them and cause us to look outwards rather than inwards. Hopefully, it would unite us to face a common challenge. This would be a long-term strategy, and by long-term, I mean hundreds, or even thousands of years. We could have a base on the moon within 30 years, reach Mars in 50 years, and explore the moons of the outer planets in 200 years. By reach, I mean with manned, or should I say, person space flight. We have already driven rovers on Mars and landed a probe on Titan, a moon of Saturn, but if one is considering the future of the human race, we have to go there ourselves. Going into space won't be cheap, but it would take only a small proportion of world resources. NASA's budget has remained roughly constant in real terms since the time of the Apollo landings, but it has decreased from 0.3% of US GDP in 1970 to 0.12% now. Even if we were to increase the international budget 20 times to make a serious effort to go into space, it would only be a small fraction of world GDP. There will be those who argue that it would be better to spend our money solving the problems of this planet, like climate change and pollution, rather than wasting it on a possibly fruitless search for a new planet. I am not denying the importance of fighting climate change and global warming, but we can do that and still spare 0.25% of world GDP for space. Isn't our future worth 0.25%? We thought space was worth a big effort in the 60s. In 1962, President Kennedy committed the U.S. to landing a man on the moon by the end of the decade. This was achieved just in time by the Apollo 11 mission in 1969. The space race helped to create a fascination with science and led to great advances in technology, including the first large-scale integrated circuits, which are the basis of all modern computers. However, after the last moon landing in 1972, with no future plans for further manned space flight, public interest in space declined. This went along with a general disenchantment with science in the West, because although it had brought great benefits, it had not solved the social problems that increasingly occupied public attentions. A new manned space flight program would do a lot to restore public enthusiasm for space and for science generally. Robotic missions are much cheaper and may provide more scientific information, but they don't catch the public imagination in the same way. And they don't spread the human race into space, which I'm arguing should be our long-term strategy. A goal of a base on the moon by 2020 and of a manned landing on Mars by 2025 would reignite the space program and give it a sense of purpose, in the same way that President Kennedy's moon target did in the 1960s. A new interest in space would also increase the public standing of science generally. The low esteem in which science and scientists are held is having serious consequences. We live in a society that is increasingly governed by science and technology, yet fewer and fewer young people want to go into science. Can we exist for a long time away from the Earth? Our experience with the ISS, the International Space Station, shows that it is possible for human beings to survive for many months away from planet Earth. However, the zero gravity of orbit causes a number of undesirable physiological changes and weakening of the bones, as well as creating practical problems with liquids, etc. One would therefore want any long-term base for human beings to be on a planet or moon. By digging into the surface, one would get thermal insulation and protection from meteors and cosmic rays. The planet or moon could also serve as a source of the raw materials that would be needed if the extraterrestrial community was to be self-sustaining, independently of Earth. What are the possible sites of a human colony in the solar system? The most obvious is the moon. It is close by and relatively easy to reach. We have already landed on it and driven across it in a buggy. On the other hand, The moon is small, and without atmosphere, or a magnetic field to deflect the solar radiation particles, like on Earth. There is no liquid water, but there may be ice in the craters, at the north and south poles. A colony on the moon could use this as a source of oxygen, with power provided by nuclear energy or solar panels. The moon could be a base for travel to the rest of the solar system. Mars is the obvious next target. It is half as far again as the Earth from the Sun, and so receives half the warmth. It once had a magnetic field, but it decayed 4 billion years ago, leaving Mars without protection from solar radiation. This stripped Mars of most of its atmosphere, leaving it with only 1% of the pressure of the Earth's atmosphere. However, the pressure must have been higher in the past, because we see what appear to be runoff channels and dried up lakes. Liquid water cannot exist on Mars now. It would vaporize in the near vacuum. This suggests that Mars had a warm, wet period, during which life might have appeared, either spontaneously or through panspermia. There is no sign of life on Mars now, but if we found evidence that life had once existed, it would indicate that the probability of life developing on a suitable planet was fairly high. NASA has sent a large number of spacecraft to Mars, starting with Mariner 4 in 1964. It has surveyed the planet with a number of orbiters, the latest being the Mars Reconnaissance Orbiter. These orbiters have revealed deep gullies and the highest mountains in the solar system. NASA has also landed a number of probes on the surface of Mars, most recently, the 2 Mars rovers. These have sent back pictures of a dry desert landscape. However, there is a large quantity of water in the form of ice in the polar regions. A colony on Mars could use this as a source of oxygen. There has been volcanic activity on Mars. This would have brought minerals and metals to the surface, which a colony could use. The Moon and Mars are the most suitable sites for space colonies in the solar system. Mercury and Venus are too hot, while Jupiter and Saturn are gas giants with no solid surface. The moons of Mars are very small and have no advantages over Mars itself. Some of the moons of Jupiter and Saturn might be possible. In particular, Titan, a moon of Saturn, is larger and more massive than our moon and has a dense atmosphere. The Cassini-Huygens mission of NASA and ESA has landed a probe on Titan, which has sent back pictures of the surface. However, it is very cold, being so far from the sun, and I wouldn't fancy living next to a lake of liquid methane. What about beyond the solar system? Our observations indicate that a significant fraction of stars have planets around them. So far, we can detect only giant planets, like Jupiter and Saturn, but it is reasonable to assume that they will be accompanied by smaller, Earth-like planets. Some of these will lie in the Goldilocks zone, where the distance from the star is in the right range for liquid water to exist on their surface. There are around 1,000 stars within 30 light years of Earth. If 1% of these have Earth-sized planets in the Goldilocks zone, we have 10 candidate new worlds. We can envisage visiting them with current technology, but we should make interstellar travel a long-term aim. By long-term, I mean over the next 200 to 500 years. The human race has existed as a separate species for about 2 million years. Civilization began about 10,000 years ago, and the rate of development has been steadily increasing. If the human race is to continue for another 1,000,000 years, we will have to boldly go where no one has gone before. Thank you for listening.
Thank you, Professor Hawking, for that series of insights and a challenge to us all.